Hello, everyone. This is question 36 of our 100 clinically oriented anatomy questions. So let's jump straight into it. The question says a 34-year-old power lifter visits the outpatient clinic because he has difficulty walking. During physical examination, it is observed that the patient has a problem unlocking the knee joint to permit flexion of the leg. Which of the following muscles is most likely damaged? Option A, biceps femoris. Option B, gastrocnemius. Option C, popliteus. Option D, semimembranosus. Option E, rectus femoris. So the most important thing that the question pointed out was the inability of the man to unlock his knee. So basically, the question is asking us that which of these muscles will be responsible for unlocking the knee? Which of these muscles helps in unlocking the knee, basically? So let's discuss unlocking and unlocking of the knee joint. So the first one, locking of the knee joint. So the locking of the knee joint is the medial rotation of the femur on the tibia, and it occurs at the final phase or the terminal phase of extension. This is of extension of the knee joint. While unlocking the knee is lateral rotation of the femur on the tibia, and it occurs at the initial phase of flexion. So locking of the knee is the medial rotation of the femur, which occurs at the terminal phase of extension. Unlocking of the knee is medial rotation, which occurs at the initial phase of flexion. So basically, it is safe to say that the muscle that will be responsible for unlocking the knee joint is definitely going to be a flexor of the knee joint, right? So an extensor of the knee joint can definitely not unlock the knee, since locking of the knee occurs during extension. So let's rule out muscles that extend the knee here. Option E, rectus femoris. Rectus femoris is definitely not part of the options we should be considering, since rectus femoris is part of the quadriceps femoris and they are responsible for extending the knee joint, basically. So another option we can rule out here is the gastrocnemius. The gastrocnemius does not act on the knee joint. Okay, it acts on the knee joint actually, since it crosses the knee joint posteriorly, so it helps in flexing the knee also. So let's leave that. So I think that's the only option we can cancel out here outrightly, since it does not have anything to do with flexing the knee. So option D, semimembranosus. Semimembranosus is an hamstring muscle, is one of the hamstring muscles alongside the semitendinosus and the long head of the biceps femoris. So what do they do? The hamstring muscles help in extending the hip joints and they help in flexing the knee joints, but they are not initiator of flexors. They don't initiate flexions. Do you get? They don't initiate flexions. So it is the muscle that initiates flexion that can cause unlocking. Since unlocking of the knee joints occurs at the initial phase of flexion, it is the muscle that initiates flexion that is primarily responsible for unlocking knee joints. Since flexion occurs at the initial phase of unlocking the knee. So on the other hand, extension is locking occurs at the terminal phase of extension. That is another thing. So now, semimembranosus is wrong. It helps in extending the hip and it helps in flexing the leg, basically the knee joint. So um it does not help in unlocking the knee joint. It's not an initiator of flexor. Popliteus. So the popliteus muscle is the major initiator of flexor of at the knee joint. Is the major initiator of flexor at the knee joint. So the correct answer is actually the popliteus muscle. So the major muscle that is responsible for unlocking the knee joint is the popliteus muscle. So the popliteus muscle helps in unlocking the knee joint. So the correct answer is the popliteus muscle. At the initial phase of flexion, popliteus muscle laterally rotates the femur on the tibia, draws the lateral meniscus posteriorly to prevent its damage, and then initiates flexion in that way. So it has already laterally rotated the femur, and then this lateral rotation of the femur, and then drags the lateral meniscus posteriorly a bit to prevent its damage, then results into flexion of the knee alongside other muscles that act as synergists at the knee joints, basically. So your hamstring muscles help in further flexion, your gastrocnemius helps in further flexion also. But the major function of the gastrocnemius muscle, which is option B, is the plantar flexion at the ankle joint. So the major function of gastrocnemius is plantar flexion. It's a very strong plantar flexor of the foot, and together with the together with the soleus makes up the triceps solaris muscle. Together with the together with the soleus, they make up the triceps solaris muscle, and they are the They are the important or the strongest, yeah, they are the strongest flexor of the ankle joint, basically. Option A, biceps femoris. Biceps femoris is also part of the hamstring muscle. Um, they help in flexing the knee. Basically, they help in flexing the knee. Biceps femoris also helps in lateral rotation at the knee joint. Also helps in lateral rotation. But these things, all these muscles, they help in these things. They are not the major initiator of this movement. So the major initiator of the motion is the popliteus muscle. That is why the popliteus muscle is the major muscle that is responsible for unlocking the knee. So on the other side now, which muscle is responsible for locking the knee? The major muscle responsible for, it's not a muscle per se, it's a group of muscles that help in locking the knee. And the group of muscle that helps in locking the knee is the quadriceps femoris. So the quadriceps femoris is made up of the rectus femoris, the vastus medialis, vastus lateralis, and the vastus intermedius. So these four muscles act together to to lock the knee. Yeah, to lock the knee. So they help in locking the knee, while the popliteus helps in unlocking the knee. So the correct answer is option C, and that will be the end of this section. I hope you understand and you enjoyed the video, and I will see you in the next episode. Thank you.